The goal of this presentation is to learn how to create a graph that represents the area under a curve using the Riemann sum. To create this graph, we'll use Maple 18. The homepage of Maple 18 is shown, and to begin, let's click New Document. To create our graph, we first need to load a package. To do so, let's go up to Tools, Load Package, and let's click Student Calculus 1. Once our package is loaded, let's go back up to Tools, let's click Tutors, Single Variable Calculus, and let's go down to Riemann Sums. This new window shows a visualization of the area under the graph of sine x from the interval 0 to pi. You can see that n is equal to 10, which tells us that 10 rectangles are used, and the midpoint Riemann sum rule is used. On the left-hand side, below our function, you can see that the approximate area is given, as well as the actual area under the curve. Now we'd like to customize this graph, so let's go back up to our function and change it to a new function. I'm going to use the function x squared. I'm also going to change my interval to be 0 to 1, and I'm going to choose 5 rectangles. I'm also going to switch my Riemann sum to the right Riemann sum rule, and let's click Display. You can see that our graph on the left is updated. The approximate area of the 5 rectangles is given, as well as the actual area. Now Maple provides an Animate button, and you can see that this increases the number of rectangles under our graph. As the number of rectangles increase, the area under the curve is more accurately represented. We can turn this animation off by clicking Display again. Maple also provides the code that's needed to create this visual. I'm going to go ahead and copy this code, and then I'm going to click Close. You can see that our document now has the visualization that we created. Now if we want to manipulate this visualization, let's go ahead and press Enter, and let's go up here to Math Mode, and let's paste our command in. I'm going to hit this magnifying glass for easy viewing. Now you can see that the command has the function that we used, the interval, the number of partitions, and the method. If we'd like to change our function, or if we'd like to create different visuals, we can manipulate this command directly. I'm going to leave the function x squared the same. I'm going to change my interval from 0 to 5, and I'm going to change the number of partitions to 15, and let's hit Enter. You can see that a nice visualization is given along with a summary of all of our inputs in our command below. Now this visualization is nice if you'd like to use it in a lab or class notes, for example. So the final thing let's learn how to do is export it. To export it, let's right-click our visual, and let's go down here to Export, and you can see a number of different ways in which you can export this. So now you know how to create a visual of the area under a curve using Riemann sums, as well as how to export it for use in your classroom.